Hi class. In this video, I'm going to go over topic 6 homework number 24. In this problem, you are taking a fair die, a 6-sided fair die, and you are rolling it twice. Each of these rolls is recorded, and you're finding the probability of different combinations of rolls. You're actually going to find the probability of the sum of the combination of rolls. So like any probability problem, we're going to find the probability by finding the number of outcomes for our event divided by the total number of outcomes. So let's start by finding the total number of outcomes. So we are rolling a 6-sided die twice. So we're going to have our first roll and our second roll. Our first roll has 6 options. Our second roll has 6 options because it's the same die rolling twice. So 6 and 6, so that gives us 36 total options. Multiply them together to get to 36. Total options, let's call this outcomes, 36 total outcomes. Okay, so out of all of these rolls, we have 36 total. Since 36 is not that big of a number, I find the best way to do this problem is to write out all 36 options, find their sum, keep that as a cheat sheet, and then use your cheat sheet to help find the probability. So when you list out the different outcomes for this, it is very common to list out the outcomes as ordered pairs. So for example, if I roll a 1 and then a 2, I would list that as parenthesis 1, comma 2. So the first thing I would do with this problem is I would go through and I would list all 36 outcomes. I'm going to do this in Excel, so I'll switch over and I'll show you my list. Okay, so what I've done is I've made a list of all 36 outcomes. When you make this list, try to do it systematically so you don't lose anything. Do all the outcomes where you'd roll 1 first, and then do all the outcomes where you roll 2 first, a 3 first, a 4 first. Typically, you're going to find it written out in this table. So if you go to look to other sources to find help on this problem, or if you go look in that Alex example, they are going to list it out in a table like this. Now, when they actually go to ask you the probability, they don't really care about whether the 1 was rolled first or the 2 was rolled second. They care about the sum of these two numbers. You are looking for the probability of the sum of something. So what we want to do now is we want to take each of these values and we want to add them together. Or not each of the values, each of the ordered pairs, add the two numbers together. So for the first one, I'd be taking 1 plus 1. And its sum would be 2. Second one, I'd be taking 1 plus 2, so its sum would be 3. 1 plus 3, its sum would be 4. So I'm going to make a second table with all of these sums, and I'm going to have them all listed out. Okay, so I have my second table listed below. My second table are all the sums. So again, let's go over what that is. So the 7 here, what this is I took the 1 comma 6 and I took 1 plus 6, and that got me the 7. This 12 down here is from the 6 comma 6, so I took 6 plus 6, and that gave me the 12. Okay, so make a list of all of those sums for each of those outcomes, and then we'll go back to the problem, and we'll start figuring out the problem. Okay, event A, part A of the question I originally started with. We need to find the probability of event A. Event A, the sum is greater than 5. So I want to go to my Excel sheet and I want to find all of the sums that are greater than 5. When I do this, I like to go ahead and highlight because it helps me count as I go. And you can always unhighlight. Finding everything greater than 5, and we're looking at our sums now. Because again, the question's only asking those sums, so all of this work we've done is to make ourselves a little cheat sheet so we can quickly go through and tally up any number in this table greater than 5. So let me zoom in. So I'm going to count all the cells I highlighted. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So 26 sums are greater than 5. So then to find the probability, I would want to take the 26 divided by the total number of outcomes. We talked about this at the very beginning, which is 36. So for the probability of part A, I'd be taking 26 divided by 36. And then that would give me the probability. 26 divided by 36 gives us 0.722, and it said round to 2 decimal places, so 0.72. All right, let me write this out to be official. All right, part B. Part B says we're looking for a sum that is an even number. So I want to find the probability that a sum is an even number. So let me go back to my Excel to get my cheat sheet table. Let me clear out all of my highlighting here so I can start fresh. All right, and I want all of the even ones. So this should end up being about every other one. So if you want to skip ahead, you can. But if you go through and highlight them, you should find it's every other one. So I'm going to go ahead and pause, and then I'll finish highlighting and resume. So I've highlighted everything that's even because we're looking for the probability if the sum is even. So then I count up everything I highlighted, and you should get 18. 18 of the sums are even. So then we go back to Alex. And then since we got 18, we are doing 18 divided by 36, and you should get 0.5. But let's go ahead and pop that in our calculator to double check. 18 divided by 36 gives us 0.5. All right, I hope this helps. Let me know if you guys have any questions.